So, Vanakkam. So, we will continue our lecture on engineering seismology. So, last class we have introduced about the seismic hazard analysis, so why it is important, what are the parameters we are expecting so to estimate from the seismic hazard we have discussed. So, we have seen that the seismic hazard analysis is the first and foremost step of the any zonation. So, this hazard analysis are carried out basically for the design of new buildings as well as to know the seismic status of the any particular region. So, this has to give the input for the infrastructure design, so that the failure of these structures, infrastructures can be reduced or minimized. So, due to any future unexpected earthquakes. So, generally this is done by considering the past earthquake data based analysis. So, with the continuation with the introduction to the seismic hazard analysis. So, today we are going to talk about the seismic study area and preparation of seismotectonic map. So, this seismotectonic map preparation is the very basic information. This map decides your hazard at a particular place. So, it should be done with a very careful thought as well as the input data and necessary models, and then collect all the information. As we have discussed the seismotectonics of India, we have seen that a different part of the India behave differently because of the different seismotectonic force associated with that. For example, east and west, we have seen that the boundaries of east and west basically transformed nature and thrust faults are there, and north completely thrust fault, but still there is a subduction earthquakes which can also take place and very deep, so about more than 200-300 kilometer deep, and then the presently continent to continent. So, convergence is contributing to the most of the rupture and fault in the northern India, which causes a many shallow earthquake. Apart from that, we also seen that central and south, they were the Cretan regions has undergone several deformation and caused a considerably damaging earthquake, particularly after 1950. So, where we have also seen why those cretans are creating earthquake. We have also understand the geology of those all these regions, and then the fault mechanism, beach balls, the VPVS ratios, Poisson ratios, the depth of earthquake. So, these are all the seismotectonic information. So, the fault type, focal mechanism type. So, these are all the data fault seismotectonic details of the particular region, which has to be compiled. So, even though we are discussed in the India level, like it's like a global or bigger scale, macro scale we discussed, but when you want to do a seismic hazard analysis or a particular site, you should narrow down to a particular place and try to understand what is the seismotectonic details in the particular region, and try to prepare a seismotectonic map. So, that is what we are going to discuss. Before starting preparation of the seismotectonic map, first of all we need to identify the seismic study area. So, what is the seismic study area? We know study area. Study area means where you are keen and interested to collect some data or interpret some result or analysis some result is the study area. So, seismic study area means actually, so generally most of the project or any kind of report, they concentrate study area means only that area. So, for example, somebody want to do some analysis in Bangalore, they consider Bangalore. They don't look at what has happened in the Mysore, what has happened in the Tumkur, what has happened in the Chennai. So, they don't look at it. But seismic, with respect to seismic action, as we have seen that the earthquake originate and propagate a waves, emit a energy in the form of seismic waves. That waves can reach throughout the world. So, that means it's not only the earthquake happening in Bangalore will affect a Bangalore, the anywhere earthquake happening in and around Bangalore also will affect. The around means what is that around? What is the radius we have to decide? How much area we should consider? That is a seismotectonic. So, the map preparation it will help. So, that area is called as a seismic study area. So, the seismic study area basically so helps to compile the required information for the seismic hazard analysis, to represent your hazard in the form of severity and repellability of ground shaking. So, what are the information which can compiled in this region actually, as we have seen that the earthquake magnitude, the distance, okay, epicentral hypocentral distance, and earthquake rate, okay, the recurrence model or return model, then amplitude, duration, ground shaking, predictive equations. So, these are all the information we need to account in the seismic steady area, which will result in the your hazard prediction, okay, like PGA, PGV or intensity, which will helpful to estimate the initial force and ground deformation failure, soil liquefaction possibility, landslide possibility, surface upset possibility, tsunami possibility. All those things are we have to estimate. These are all the seismic hazard, okay, which can expected, which is the function of your seismic steady area what you are considering. So, if you look at the map, this one, so the steady area is actually the region where you are looking at your hazard estimation. Okay. So, if the Bangalore city I want to estimate a hazard, the Bangalore BBMP area, okay, is a steady area. Okay, that is the steady area, that may be in any shape. So, depends upon the place to place, some place you will have the a proper circular, some place you will have the irregular shape, some place you have even linear shape. Okay. So, that it does not matter. Okay. So, the steady area is where you are trying to predict hazard is the steady area. Okay. So, the seismic steady area is area where you need to consider, okay, whatever parameter we discussed in previous slide, all those parameters need to be considered, okay, within that radius is a seismic steady area. So, generally the seismic steady area will be the several times of the your steady area diameter. So, for example, this is the, I say it is a Bangalore, okay, if this is the Bangalore, okay. So, my steady area will be this much radius. So, how I will decide this much radius, that is what we are going to discuss, what is the practice we do. So, what are the lacuna in that, okay, what way we can select more representative steady area. Okay. So, in the steady area, okay, so in the steady area and seismic steady area you have to identify. So, then after identification of the seismic steady area, basically we call it as a SSA. Okay. So, the SCA is a steady area, SSA is a seismic steady area. You need to understand geology, okay, deep geophysical data, fault study and map, remote sensing, seismic data. So, these are all the information which is a part of your seismotectonic details, that is what we have seen that, no. So, those details should be compiled, okay, and geo-referenced and plotted in the seismic steady area. So, let us see how the seismic steady area is generally selected. So, the I mean as per the literature in India concern, okay, so the hazard analysis, particularly when they talk about the systematic hazard analysis, I understand that the first work was done by the R.N. Iyengar, okay, his group and his team. So, Professor Raghukant right now is faculty at IIT Chennai. Okay, so IIT Madras is the faculty. So, they have done, okay, so they referred a seismic steady area. So, that is what I come to know what is the seismic steady area. So, they consider a seismic steady area some X radius based on the regulatory guide. Okay, the regulatory guide 1.082. What is this regulatory guide? This is actually regulatory guide actually released by the US nuclear agencies. Okay. For doing any seismic hazard studies, okay, one has to consider as per regulatory guide, this is the seismic steady area, okay, which says that, so the investigation should be performed at 4 level, okay, with the degree of detailed based on the distance from the site, okay, this is the distance from the site, nature of the quaternary tectonic regime. So, based on the tectonic regime, the geologic complexity of the site and region. So, the site geology and complexity also need to be accounted. Existence of potential seismic source and potential surface deformation. So, they say that you should do a 4 level of study, okay, to identify a starting from the your seismic steady area. So, what is that 4 level? So, the within the radius of 320 kilometer, which is equal to 200 miles. They are given that any seismic steady area you should take as a 320 kilometer or 200 miles, which is basically given as a 200 miles. Okay, if I convert the US system, they use miles, no. So, if we convert that into the kilometer, it comes to roughly 320 kilometer. So, one has to conduct regional geological seismological investigation to identify the seismic source. So, people has to go through a literature and identify a seismology and geological investigation and identify the different seismic source in this radius region. This investigation should include literature review, study of map, remote sensing data, if necessary on-site ground recognition. So they say what are the detailed study you should do. So within the radius of, so that is the first level they say for this one. So within the radius of 40 kilometer, like 25 miles of the site, okay, site vicinity, the geological, seismological, geophysical investigation should be carried out. Greater details, you can see greater detail means you should go do the field studies, okay, regional investigation, identify and characterize all the seismic and surface deformation potential of the any capable source in the area. Okay, that is what you should do in the 40 kilometer radius. The seismic potential of the seismogenic source and demonstration of the such structure are not present. So you have to do the detailed study and demarcate which are the potential seismogenic source, which are the not potential seismogenic source. That we have to demark by doing this detailed analysis. So site with capable of tectonic source within the radius of 40 kilometer may be require a more extensive geological and seismological study. If you found that there is a potential seismic source, okay, then you have to take a further detailed investigation. Okay. So that should be done again another scale. Okay, that is like 5 miles or within the radius of 8 kilometers. Okay. So the detailed geological, geophysical studies and then geotechnical investigation should be conducted to evaluate potential tectonic deformation in the near ground surface to assess a transition characteristics of the soil and rock if there is a potential seismic source. So this will be the level 3 level. So the within the radius of approximately 1 kilometer from the site, which is like roughly 0.6 mile of the site, very detailed geotechnical, geophysical, and then geotechnical, geology, geophysical, geotechnical engineering investigation should be conducted to assess specific soil and rock characteristics, so that you understand how the wave propagation going to change when earthquake comes. So that is the whole idea of this. So they also given, okay, after giving this minor discussion in the detail, they also suggested that the area of investigation may be need to be expanded beyond the specified above in the region, include capable of tectonic source relative to the high seismicity, complex geology and regions of that experienced large geological recent earthquake, identify historical record and follow seismic data. So this is what they are given. So this was basically guideline given by the US Atomic Regulatory Guide. Okay. So they are given this guideline to basically do seismic hazard analysis of nuclear power plant located in the northeastern America. Okay. So because the western side they don't have much nuclear power plant. So the eastern side they place lot of nuclear power plant. That power plant seismic hazard analysis, this is the guideline given. So the Raghukant actually one of his paper he quoted this regulatory guide and used 300 kilometer, okay, as a seismic study area for the analysis in the some I think Mumbai city or Delhi city somewhere. So this was the first work where they consider the seismic study area officially to account. Okay. So when I was working on this research area, as I told you that I not only adopt a procedure, I also try to understand why we adopt that procedure by doing the research area. I initially adopted like 350 kilometer for the Bangalore. Okay. So because the 320 was written in the regulatory guide, 300 was followed by the Raghukant, then we taken a 350. Further I tried to investigate why that seismic study area is very important. So that investigation and findings only helped me to demarcate how to estimate a seismic study area at a particular place. So what I did actually, look at how the damage pattern in the northeastern USA. So northeastern USA is actually also called as a stable continent region. Okay. So there the earthquake occurrence similar to peninsular India, but they didn't have experienced any big earthquake, okay, before release of that regulatory guide, even after release of the regulatory guide until now. So can we adopt a similar procedure, a similar concept in the peninsular India? So when I am discussing with the seismotectonic details, I told you that our crust formation, okay, the thick the crust formation in peninsular India, particularly the Craton regions are thin, about 39-35 kilometer thick of crust. When it goes to Himalaya, it is a thicker, about 70 to 80 kilometer. That is what we have seen. This thickness is lowest among the world over anywhere in the intraplate slab crust thickness. Okay, that is what we understand. So that means you are taking up similar kind of recommendation, even though it is a similar tectonics, both of them are intraplate in nature, can it be right or wrong? So that is the question I pose myself, and try to understand whatever available recorded, okay, or the earthquake which is experienced very recently, and how the area, okay, the felt area like intensity, okay, because the measured data are very limited. So the intensity indicates that how much distance people are feeling similar kind of intensity values. Okay, so that I try to study by taking a two typical earthquake, and then decide that whatever we are doing seismic study area, right or wrong, how we should decide. So let look at here, because I started my research on the Bangalore region. So then further I did actually for the Coimbatore. So I take here South India as a example for demonstrate how the seismic study area has to be selected. So let's see the US map. Okay, this is actually the 4.9 magnitude, okay, local magnitude in eastern North America. You can see the intensity map, okay, you can see the intensity map, okay, the 4, the 6, okay, 4, very closely you can see the intensity map. Okay, so this is the distribution of the isosysmal map. Let's see the same kind of map here, okay, like you can see here. Okay. So it very clearly indicates that, okay, the distribution of this and this are completely different. So we have basically a longer distance, the similar kind of intensities are reported. Okay, this was a magnitude of 4.7 occurred on 2004 in the Pala region. Okay, this is called as a Pala earthquake. Okay, so here you can see that there is a considerable variation in the intensity, where here this was actually a smaller distance, here it is a bigger distance. So which indicates that the wave propagation in the peninsula in India may be different than the wave propagation in the Northeast America, even though regions are similar. So that means the damage level, since the wave propagation or intensity indicate a damage level are felt. So similarly the bigger earthquake may cause a larger damage than the US. So then I look at what are the isosysmal maps are present or prepared in India for the past earthquake. So when I was talking about the isosysmal map, I told you what is the importance of that. So now you realize that where it is important, because since we don't have the recorded data, the alternate only available data is the damage map or the isosysmal map or intensity map. That map I try to study. So this is the typical isosysmal map which is published by the Geological Survey of India for Coimbatore earthquake. There was a Coimbatore, okay, so earthquake during 1900. Okay, 8th February there was earthquake with the magnitude of 6.3 or 6 to 6.3. You can see that, okay, the 4 intensity like 4 to 5 is the intensity which is interested for the any civil engineers, where your structure get the cracks or start vibrating, and then the duckling and all those things will happen. So that intensity value we should look at. You can see the distribution of the isosysmal. So these all controlled by the your local geology. So that means taking up seismic study area, considering the local data is more appropriate than using a universal approach, okay, or universal procedure, because nobody telling us to take, we are only whatever literature available, we just going through and taking that. So instead of taking some literature which is elsewhere, which may or may not applicable to us, let's see, understand our own earthquake. That is why we discuss here seismic events or earthquakes reported in the India. We have given a few classical examples, no? So that isosysmal map, understanding of that damage will help you to identify your seismic study area. Okay, so now you understand what is the importance of that. So by looking at this, one can decide what intensity the building damage or the human felt uncomfortable, that intensity they can decide. Based on that, they measure how much distance it is from the isoseismal map and take that distance as a minimum distance for the seismic steady area. So, that means taking up seismic steady area may not be uniform throughout the India, as we have seen that the southern part behave differently, western part behave differently, central part behave differently, and east and western part behave differently, northern part behave differently. If we recall all the isoseismal map what we discussed, some of the map even it goes up to like 1000 kilometer with the intensity of 4 and 5 we have seen. So, those kind of places if you do, basically you have to consider your seismic steady areas here so much. And this case particularly this shows a maximum distance of close to 3.76 degree, which is multiplied by the 110 if you do, it close to 450 or 500 kilometer radius you will get. So, this is how you can select a seismic steady area. So, now we understand the steady area and a seismic steady area. Once you select a seismic steady area, then you try to see what are the geological formation. So, when I talk about the South Indian geology, I told you know. So, understanding of geology will indicate how more the complex is geology, you can expect more and more seismic activity in this region. So, similarly, this is your Bangalore, as I told you that steady area. So, this is my seismic steady area. This is the radius where I try to collect all the geological and the seismotectonic features. Here you can see that this is basically a Kadapa this one, and then the nice granitic terrain. Okay, so all the geological formation you can see. Okay, so these are the similar type, more complex geology. Okay, so these are all the place more complex geology. Okay, so this is the way you should compile. So, this geology and seismotectonic details is already may be published. So, as I told you that during 2004 only available data was the seismotectonic map published by Geological Survey of India, but now there are a lot of studies are available even for a Bangalore. Okay, so those kind of studies based on the recorded data in the region should be considered. So, you compile a geology and seismotectonic data and try to the, as I told you that the seismotectonic map published by the Geological Survey of India, it consists of lot of seismotectonic details, okay, like location of the fault, lineaments, okay, shear zone, geological boundary, earthquakes, heat flow, magnetic flow, depth of earthquake, all those information is compiled for the whole India and published as a seismotectonic map. That map is actually available for the cost. So, you can look at this is a typical map. It has actually 43 sheet of this kind of map, and each India is divided as a different grid. Each grid this kind of details are provided. You can see even the beach ball they are given. You can see the beach ball. Okay, the depth of size of earthquake, depth of here. So, there are all the geological features. Then the fault, heat flow map. So, this is a typical sheet 21, sheet 20. Okay, so like that the Bangalore comes under the 4 sheet. So, you have to take that sheet. Now, it is available as a soft copy. When I was doing actually we have completely digitalized all of them and try to merge and create this map actually, okay, by removing the by creating different layers in the AutoCAD. So, sometimes these maps may be very low, okay, very old. Okay, for example, I said 2004 I did my analysis. So, 2000 map is actually quite new, but the same map if I do now, okay, it's completely old. So, I have to look at what was any updated studies done on this region. So, there was a updated study, means generally geologists and geophysicists and remote sensing people, they do the studies what we discussed in the seismotectonics of South India, we discussed based on the data, they do lot of analysis. No? So, they do that kind of studies and try to publish a map which shows a active seismic sources. Okay, so, there were dead seismic sources, lineaments, okay, earthquakes, all those days. So, this is a such study carried out for the Karnataka, where authors are used remote sensing image. Okay, he is Dr. Ganesh Raj from ISRO scientist. We had actually interacted with him. We have used his map 2001 map in the 2004 analysis, where he is also shared our publication along with us for the Bangalore microzonation work in the hazard analysis. So, where they plotted, identified all the lineament and superimpose earthquake data, minor earthquake data, try to identify the active lineament and comment about that how these lineaments are active, why it has to be included in the seismic hazard analysis. Okay, they carried out the study, part of his PhD. So this paper is published as a Ganesh Raj and Nanjundayya's guide. So that information also we need to consider, any remote sensing data in the region. Okay. So then, so remote sensing data, as I told you that, so remote sensing data you can also collect and verify when your data world analysis are available, you have to look at that. So if you see the remote sensing data, generally you can able to get the linear feature, lineaments, okay, the seismic activity, the fault or lineaments, okay, so you can easily get from the satellite data. This is a typical satellite data which shows some of the lineament. Okay, you should not get confused with the lineament and road. So you should always approach a expert on remote sensing to process your satellite data. Here also we have taken Ganesh Rad and his group for the Bangalore analysis, where we have been seen this lineament and this lineament as a new. This is called as a Mandya Channapatna Bangalore lineament. Okay, so this is basically IISc. This is the roughly a Bangalore city. Okay, so apart from identifying this kind of sources, you should also go and physically verify how it is geological. So this we have also done that. So this is actually the Kanwa reservoir. People who are in and around Bangalore will be familiar with that. So you can see that this is actually the reservoir where this is the part of the lineament. This is the downstream and upstream side of the Kanwa reservoir. So you can see that if we are saying active based on the some earthquake data and the satellite data, how field it is varies. So we went and then we have taken a geological studies on that with the help of Ganesh Raj and talking to the people. So and then what is their experience on earthquake, how. So they are all given, even said that when Bhuj earthquake was there, people living in this part of the area felt that vibration more than a people living here, okay, or other side. So and even the Sumatra earthquake, they said they felt. Okay, so that means this zone, whatever we are talking as a lineament or this one, this is a deformation zone in the crust. Okay, that is what we can take. So then we let see the geological sample. We have collected a geological sample on the left side and right side. You can see the rock formation orientation. See, you can see. So this is how the rock is oriented on the one particular direction. In the other direction, you can see the rock how it is oriented. Same type of rock, it's oriented. So that means once this rocks may be similar, there may be breakage in the geological period which we are not seen, like several thousand years or million years old, then these rocks are get turn around because of this breakage and movement of the taken place in that region. So this kind of field studies need to be carried out, okay, to identify whatever information you are getting right or wrong. Okay. So you can also look at some of the features, okay, subsurface features, okay. So on this one, the fracture surface, evidence and movement of the ground, okay, by looking at the geological rock samples, soil samples, all those things. Presence of two different material type of same location, that is what we have seen, missing and repeated and truncated strata. So which indicates that there was some kind of movement taken place in the long. So topography, scrap, anomaly, stream gradient, changes in the elevation of the shorelines, that we will show in the next slide. Abrupt changes in the groundwater table, gradient, okay, chemical composition and presence of hot spring. Within a short distance, if you see all these irregularities, which indicates that so there was some kind of geological disturbance is happening in that area. So lineament caused by the topography or vegetation. Geophysical indicates subsurface faulting, including the steep magnetic gradient, difference in the seismic wave velocity. So all those data also you can do if there is a possibility. So you can see that the fault scrap is actually topography expression, faulting attributed to the displacement of the land surface by the movement along the fault. Fault scrap often contain a highly fractured rock on both odd as well as weak consistency. Height of the scrap generally, so formation equal to the vertical displacement. So you can get here this kind of geological features. You can see, so same land down due to the this kind of seismic activity. So you can also see here, see this first. Okay, so you can see here. So this is a raised up. Okay, so same soil here, same soil here. So this kind of geological land formation, and it is called as a fault scrap. This gives the evidence. Okay, so this data, okay, we have to basically collect it and U sheet in the this one. Then identification of the shoreline in the sea area, there will be shoreline changes. Okay, so in the water bodies and all, you can see here how the rocks are there. Okay, so you can see how the see. Okay, so see there is a. So these are all the features you can study basically, and by doing a geological investigation in the site. Okay. So abrupt changes in the groundwater elevation due to the increasing the pore water pressure also causes a liquefaction in that hot spring. Okay, produce here this one. So this is the hot spring, where generally hot spring comes because of the magma eruption in the particular area. So somewhere suddenly if you have the hot spring in the ground, it indicates that there is a geological activity is taking place. So this is the, so before event how the hot spring was, after the event you can see. So before earthquake, after earthquake, where you can see the activity physically. So if you have this kind of hot spring, one has to be very careful, there may be chances of seismic activity in that region. So the seismotectonic map, okay, should include all this geological and features parameters and try to compile them, okay, by doing a detailed analysis. This is like lineament identification in the satellite image again. So you have to include that, and where you can try to even understand what type of fault, how the movement taking place in that particular location by looking at a geological deformation. Okay, the shear zone activity happening at a particular place will be visible as a shear zone, where you will have the very fertile land. In between you will have the rock terrain, and suddenly you will have the very fertile land for a several kilometer width. So like we have seen in the previous slide, no. So here this here you can see that this. So here, so basically this region is very fertile, but this is very hard rock. So this kind of geological differences will give you the your indication of the seismic activity in this. So all this information need to be compiled and prepared as a seismic source map, okay, which is called as a seismic source map, which has to indicate all the fault in the region, active fault in the region from the remote sensing, field observation, photo studies, literature as on date when you are doing the hazard analysis. You should not take 10 years back a map published by somebody X and do the hazard analysis. If you do that, you will end up in the trouble, okay, by deciding the your seismic study area. So this will help you to estimate a more reliable hazard values as we try to map all the possible seismic sources due to this kind of detailed analysis. Okay. So this is actually a typical seismotectonic map, source map you can see. So again for the Bangalore. So where you can see we have used like a neotectonic fault. Okay. So this one, the fault involving the cover. Okay. So the some fault where it is not hidden, it's in a fault involving the basement cover. Okay. So the green one. Okay. So then the fault involving the basement. So other type. So like that we have different type shear zones. Okay. So the shear zone. So shear zone. Okay. Lineaments. So all those information has to be compiled. Okay. And then made a data, okay, like how many sources are there, each source has to be systematically numbered. You can see here, you have to systematically number by assigning a fault 001, fault 002, something like that, and then highest parts and lowest part, what is the, how many lineaments are there, how many shear zones are there, what is the depth of earthquake this area experience, what is the VP value, VS value, Poisson ratio of this region from the previous literature. If it is not available, you have to do detailed study, depends upon the project. Okay, if you are doing for the important project like nuclear power plant, dam and multi-stories, it's time investing on that, so that your reliable hazard estimation will happen because of these maps. So this is how you can prepare a your hazard analysis process of preparing a seismotectonic map. Okay. So the seismotectonic map is the base information source about the seismotectonic character of the region, which includes the seismic source, deep geophysical data, okay, so which VP, VS and Poisson ratio, crust thickness, depth of the earthquake, number of fault, lineament, active sources, all those information should be compiled for a seismic study area. So where a seismic study area is to be arrived based on the intensity experienced in the region, intensity map or isoseismal map, or if you have the big earthquake recorded data, that also can be taken as a reference to decide a seismic steady area. So as on now, I don't recommend any seismic steady area for any particular location. You have to do your own homework and try to arrive a seismic steady area. So if you want to check the how to arrive that, you can refer some of my publications done for Coimbatore, okay, the KSR dam and other regions where we have given a systematic approach how to arrive a seismic steady area radius. Okay, then how to prepare a seismotectonic map. Okay, so this is the base map where we identified all the active fault sources and mapped them. So with this we will move to the next step of the hazard analysis. Okay, so that is the seismic data collection and then seismic data homogenization. So that we will discuss in the next class. Thank you very much for watching this video. So I will meet you in the next class. Thank you.